Good morning, afternoon, or evening, cats and dogs. This video will cover the lesson 2.6 guided notes on the coordinate system. After our mid-unit 2 quiz, I believe you had some time to start working through this lesson. So some of these things you may have already seen, which means you can kind of maybe skip through some portions of this video or skip over some parts of the video. So I want to start by looking at what the coordinate system encompasses. Our x-axis goes from left to right. It's our horizontal axis. Our y-axis is vertical. It goes up and down. And our origin at 0, 0 is where the x-axis and the y-axis meet. 0, 0 is also where we start when we go to graph our points on the coordinate plane. One of the things that might be unfamiliar to you is our quadrants. Our coordinate plane is split into 4 sections. We call them quadrants, which makes sense since quad means 4. Quadrant 1 is what you would have learned to graph with back in elementary school. It's in the top right-hand corner, and it's where all of our values happen to be positives. We go counterclockwise. That can get a little bit tricky to remember. To identify our quadrants, we go counterclockwise. So quadrant 2 is in the top left-hand corner, quadrant 3 is in the bottom left-hand corner, and quadrant 4 is in the bottom right-hand corner. So again, we go counterclockwise. Anything that's on either the x or y axis is not technically in a quadrant. We'll talk about that in some of our examples. Our ordered pairs are always going to be in parentheses, and they're going to be of the form x comma y. The x coordinate tells you how far left or right to go. If it's negative, you go left. If it's positive, you go to the right. Our y coordinate tells us how far up or down to go. If it's negative, you go down. If it's positive, you're going to go up. Keep in mind you always move left or right first, then you move up or down. You've got to run before you jump instead of jumping and running. So we always go left or right, then we'll go up or down. That's going to be important in just a few moments. So our next set of questions, you can actually already see these up on your screen. So the answers are kind of already here, but this is the easiest way to do this ahead of time instead of trying to do it with you during the video. It says in the directions to graph and label each point on the coordinate plane. Name the quadrant in which each point is located. So point A is at 2, 6. We're going to start at 0, 0, go to the right 2, up 6, put a point, label it with an A. It is in quadrant 1. B is at -1, 4. Start at 0, 0, left 1 for -1, up 4. We're going to graph point B. And you really want to make sure you can accurately graph points. It's going to be a huge part of some of your future lessons. Not as much this year, but definitely in Algebra and Algebra 2. So this point is in quadrant 2. What I do suggest students do sometimes is actually, before they do the problems, go through and maybe label your quadrants on your graph. That way it makes it a little bit easier when you go to label the quadrants for your points. We do use, and I forgot to mention this, someone always asks, but we do use Roman numerals to represent the quadrant numbers. I'm not sure why, but just get used to that. I mean, 1 is an I, 2 is 2 I's, 3 is 3 I's, and then the tricky one is 4, which is IV. In world history, a lot of times you talk a little bit about Roman numerals. Point C is at 0, -5. Be careful with these ones where either your x or your y coordinate 0. Students struggle with those frequently. 0, -5 means I start at 0 and I go down 5 and put a point. It is not in a quadrant. We just write none. Point D, -4, -3. Start at 0, 0, go left 4, down 3, put a point and label it. This point will be in quadrant 3. Number 5, E is at 2, 0. We go right 2 units, up or down 0, label it with an E, and it is not in a quadrant. Point F, 3, -2. Start at 0, 0, go right 3, down 2, and we will end up in quadrant 4 for point F. Number 7, G is at -4, 4. Start at 0, 0, left 4, up 4, put a point and label it. It's in quadrant 2. Point H, 2, -5. Right 2, down 5, label it with an H. That's in quadrant 4. Point I, 6, 3. Go to the right 6, up 3, put a point, label it I, and it's in quadrant 1. I think someone was being a little funny there, making sure I was in quadrant 1. That's math teacher humor for you. Number 10, we have -5, -8. Begin at 0, 0, go left 5, down 8, put a point. This point will be in quadrant 3. Number 11, 3, negative 5, go right 3, down 5, put a point. It's right next to H. This will be in quadrant 4. Finally, number 12, negative 7, negative 3, left 7, down 3, label it with an L. It's in quadrant 3. What's nice about this graph that we won't see the entire lesson through is that all of these lines are labeled. You don't have to label them on the coordinate plane, but it does make things a little helpful to have them done that way. So if you're ever struggling, feel free to label the numbers on the coordinate plane, because a lot of times this space will be blank and they won't be listed. You'll have to know that they go up here, 1, 2, 3, 4, 5, etc. They go positives here again, 1, 2, 3, 4, 5. And then these guys are our negatives, negative 1, negative 2, negative 3. The further you get from 0, remember, the bigger the numbers are going to get here, and the smaller the numbers are going to get for the negatives. So just double check that. All right, our next set of questions ask us to name the ordered pair for each of the points from the graph. So let's go ahead and do that. Let's locate point A. Point A is right here. We go left 2, up 2, so that will be negative 2, comma 2. It does not ask for quadrants here, which is nice. Point B, let's locate that one. That one's here. We go right 3, down 7, so this will be 3, comma negative 7. Point C is right here. We go left 4, up or down 0, so negative 4, comma 0. Point D, go right 3, up 5, this will be 3, comma 5. E is right here. We go right 4, up 2, 4, comma 2. Point F, here. Go left 6, down 3, negative 6, negative 3. Slide that up a bit. Point G is here. Right 2, down 3, 2, negative 3. Point H, right 5, up 1 is 5, comma 1. I, left 7, up 6, negative 7, comma 6. And finally, J, we are going to go to the left 5, up 5 is negative 5, comma 5. I'm going through these quickly because I know you do have experience with graphing points from your 6th grade math and maybe even earlier. But again, if you need to go back and review some of these things or ask any questions, don't be afraid to do so, because if you cannot graph points, you're really going to struggle once you get into algebra, geometry, and algebra 2. All right, so our next questions are more pre-algebra level questions than 5th and 6th grade concepts. It says to complete each of the tables below, then graph and connect your points on the coordinate plane. 23 says the difference between Laura and Evelyn's golf scores is 3. If X represents Laura's score and Y represents Evelyn's score, make a table of possible values for X and Y. Graph the ordered pairs and describe the graph. So if we know that the difference of their scores is 3, we can write this as X minus Y equals 3. So you can choose any values you want for X to make this true. So I actually started with X equals 7. I definitely tried to stick with some positive values. I thought that might be a little easier. And I have to think, 7 minus what gets me 3? Well, that's 4. Next one I did was 6, just to keep the pattern going. 6 minus what is 3? Well, that's 3. 5. 5 minus what is 3? Well, that's 2. 4. 4 minus what is 3? That's 1. Finally, I chose 3. 3 minus what is 3? That's 0. Let's graph these. So 7 comma 4. We got to go to the right 7. 1, 2, 3, 4, 5, 6, 7. Up 4. 1, 2, 3, 4. Hopefully I have that in the right spot. We'll see soon if not. 6 comma 3. Right 6. Up 3 is going to be right here. 1, 2, 3. Good. 5 comma 2. 1, 2, 3, 4, 5. Up 2. We've got 4 comma 1, that's going to be right here, and 3 comma 0 is going to be right here. I do like to connect these with a line, and I do put arrows on both ends. If you don't have arrows on both ends, it's not necessarily wrong. We'll talk more about situations when you definitely need to have arrows. This situation doesn't necessarily go on forever, but we'll connect those. Some students like to just connect the dots and not go any further. But describing this graph, I didn't type anything in here. You don't necessarily need to write anything, but obviously this is a straight line graph. You'll see a lot of graphs in real life that sort of go up and down versus just being a straight line. This one just happens to be a straight line graph, which is what we're working with here in this course and pretty much most of algebra as well. All right, number 24, the sum of two soccer team scores is 6. If X represents the score of one team and Y represents the score of the other team, make a table of possible values for X and Y, graph the ordered pairs, and describe the graph. All right, so for this one, it's the sum of two team scores. So that means we need to have an addition statement. So I've got to have X plus Y equals 6. So let's choose some values. I'm just going to slide all of these down. I chose 6 as my first, since 6 plus 0 is 6. And then I did, whoa, don't want to do that, don't want to do that, don't want to do that. There we go, goodness, sorry about that. 6 plus 0 is 6. I chose 5 because 5 plus 1 is 6. 4 plus 2 is 6. 3 plus 3 is 6. And 2 plus 4 is 6. I did keep the numbers positive in this case because while on the last one we could have negative golf scores, you can't have a negative score in soccer. So I did stick with positive values in this case. So we could have gone higher, but the problem would be if we had 7 plus negative 1 equals 6, the second team can't have a score of negative 1. But I could have gone here if I would have done 1, I could have done 1 and 5 here, and I could have done 0 and 6. So there were a couple of other options, but it wasn't an unlimited number of options for this situation. So let's graph these. 6 comma 0, 1, 2, 3, 4, 5, 6 is going to be right here. 5 comma 1 is going to be right here. 4 comma 2, 3 comma 3, and 2 comma 4. So really this one, I'm not going to put arrows on both ends because it's one that cannot really continue forever, but it could go up to 0, 6 would be an option in this case. So it's another straight line graph. I'm actually connecting all of these, which also seems kind of unusual because truly you couldn't have any points in between the dots that are given. For example, someone can't have a score of 2.5. But I am going to connect them here just to show us the general trend. But there are situations where you can't have a score in between those either. But we can see that these points form a straight line. And pretty much most of what we're going to talk about, the points will form a straight line. All right, next one is number 25. For the graph below, create a table showing the rule and the values for X and Y. So what I did was I labeled each of these ordered pairs. So the one all the way on the left here is -3, -1. The next one is -2, 0. That's this guy right here. Then we have -1, 1 right here. We have 0, 2, which is this guy. And then finally 1, 3. So we need to think like, what is the rule? What is the relationship between X and Y? Do you know? If you were thinking that if you add 2 to X, you get Y, you're correct. So this is not the only way to write it, but I was thinking Y is equal to X plus 2. Oops, X plus 2. If you add 2 to whatever X is, you'll get Y. We could write this in other ways as well. We could write that X minus Y equals -2. So you do have some other options, but I think this is probably the best way to represent it, that Y, which is our output, is equal to whatever our input, X is, plus 2. A lot of these questions, by the way, I'll point out, you'll definitely see some graphing or identifying points on the coordinate plane, knowing their quadrants as well, but you won't have any problems similar to 23, 24, 25. This is just to get us ready for when we do some of these relationships and tables later on this year and even into algebra next year for you guys. Now, what you will have on your test is a problem like this. So 26 says, on the coordinate plane below, draw a triangle ABC with vertices or endpoints at A, 4, 2, B, -2, 1, and C, 5, -2. So you can see that I already graphed these points for us. So take a look, graph them on your paper as well. Now, it says to multiply each coordinate of the vertices by -1. List the new coordinates below. Name the new coordinates, A with a little like tick mark after it. We call that A prime, and then B prime and C prime, like prime number. We do want to differentiate it from what we originally had. If we name it A again and it's a different point, that doesn't really make a lot of sense. So we do give it a new name. So let's multiply each coordinate by -1. So 4 times -1 is -4. 2 times -1 is -2. So A prime is -4, -2. Let me go ahead and graph that on the coordinate plane because as you see down below, it asks us to graph these new points. So -4, -2. So 1, 2, 3, 4. -4, -2. We'll label this as A prime right here. All right. -2, 1 was B. Multiply each by -1. -2 times -1 is 2. 1 times -1 is -1. So we get 2, -1. So let's go ahead and graph that. 1, 2, -1. This will be B prime. It's kind of on the line there, line BC. C, we had 5, -2. Multiply by -1. 5 times -1 is -5. -2 times -1 is 2. So we go left 5, up 2, 1, 2, 3, 4, 5, up 2, and this will be C prime. Let's go ahead and connect these. I'll have to change the color of my lines as well. So I've got this. And let me go ahead and change the color of my lines. Hopefully this doesn't get too tricky to do here. There we go. All right, so we can see original triangle ABC compared to the new triangle. We call this the image triangle A prime, B prime, C prime. You'll see more of this in geometry if you choose to take geometry. And I believe also even in algebra. And last year at the end of the year, we did actually have time during our virtual learning to get to some problems like this. So it says to describe how the new triangle compares to the original triangle. I think probably what you notice is it was somewhat of maybe like a rotation. So we sort of took this triangle and we rotated it around. So A came over here to A prime, B came over here to B prime, and C came up here to C prime. But they do happen to be the same size and the same shape. It just looks like perhaps maybe a reflection, but in this case more of a rotation since B and C shifted positions. So again, I just like to compare the new triangle to what we had originally, which you might have to do on the test. I don't remember off the top of my head. All right, let's look at another one of these. Number 27. On the coordinate plane below, draw a rectangle DEGF with vertices or endpoints at D, -2, 4, E, 5, 4, F, -2, -3, and G, 5, -3. All right, so you can see that I did that here. Now, it does ask us to subtract 3, and I'm trying to remember, let's see, 1, 2, that was 5, so 7 by, looks like this is actually a square, so it's not even just a rectangle, it happens to be a square as well. So this one asks us to subtract 3 from each coordinate of the vertices and to list the new coordinates below. We're trying to get you some practice with not just graphing, but also multiplying, adding, and subtracting with integers. So D was originally -2, 4. So subtract 3 from -2. -2 minus 3 is -5. 4 minus 3 is 1. So -5, 1. 1, 2, 3, 4, 5. -5, 1. That's D prime. E was originally 5, 4. Subtract 3 from each of those. 5 minus 3 is 2. 4 minus 3 is 1. So E prime is at 2, 1. It's going to be right here. F, let me slide this up. So F was at -2, -3. -2 minus 3 is -5. -3 minus 3 is -6. So we've got -5, -6. So 1, 2, 3, 4, 5, 6. This will be F prime. And then G, 5 comma negative 3. 5 minus 3 is 2. Negative 3 minus 3 is negative 6. So G prime is going to be at 2 comma negative 6, which is going to be right here. I can use some of my other points to help me since it happens to still be a rectangle, or in this case, a square. So let's go ahead and connect these, and then let's compare to the original. Just like the last one, you're going to notice that it's the same size and shape. In fact, this one was just shifted. We call that a translation, a word you'll see, if not later on this year, then definitely next year. But it was shifted to the left and down. And we could be even a little bit more specific. Let me just change the colors of these lines here to be red. So we've got our image here. You can see that D, for example, was shifted 1, 2, 3 units to the left and 1, 2, 3 units down. And that same thing happened to E, G, and F. So our new figure, our new image is shifted to the left 3 and down 3, which kind of makes sense based on subtracting 3 from each of the coordinates. You will eventually talk about what happens if you maybe multiply each of the coordinates by something other than 1. Like you might even be able to think, what happens if I multiply them by 2? What happens if I multiply them by 1/2? These are things definitely to think of. And if we were in the classroom, we'd probably try some of these things, but I also don't want to make your video like 40 minutes long either. All right, we've got 2 more questions to finish up for this. It says to name 1 point in each of the 4 quadrants. This is just for us to practice each of our quadrants here. So quadrant 1 is all positives. That's pretty easy to remember. So an example would be 2 comma 5. For quadrant 3, they're both going to be negatives. So I chose something like -4, -4. You might have something similar to that as well. You don't have to have these exact points. These are just some examples. Now for quadrants 2 and 4, and I realized I was thinking through this, I switch these around. So let me just fix this really quickly. Not going to restart the video at like 22 minutes in, but I realized that I switched them around when I typed them in. Silly me, it happens. We all make mistakes. So quadrant 2 and 4, those are the ones that are a little bit more challenging to figure out. Quadrant 2 is in the top left-hand corner. So an example could be -3 comma 5. And quadrant 4 is in the bottom right-hand corner. So an example could be 3 comma -8. So 1 and 3 are usually a little easier for students to remember since they're all positive or all negative. 2 and 4 are trying to figure out which is positive, which is negative, and is a little tricky sometimes. Don't forget though, for our quadrants, just to give you a graphic of this, if we're looking at our coordinate plane, looking like this, remember quadrant 1 is top right. We go counterclockwise, so 2, 3, and 4. Not even sure how often we say counterclockwise anymore since most of our clocks are digital. All right, last one, number 29. Jefferson says that if you interchange the coordinates of any point in quadrant 3, the new point would be in quadrant 3. Tori says the new point would be in quadrant 1. Who is correct? And explain your reasoning. So let's think what happens. If we have a point that's in quadrant 3, for example, delete that, -5, -8, where they're both negatives. We mentioned that before. And we interchange the coordinates, meaning we switch their position. So we rewrite it as -8, -5. When we do that, we still end up with both coordinates being negative, which means it will still be in quadrant 3. So what I said for my explanation here is that Jefferson is correct. The point would still be in quadrant 3 since each of the coordinates would still be negative, and points in the third quadrant have 2 negative coordinates. All right, I know that was kind of a long video. Hopefully you were able to skip through some parts. The main things you want to remember are how to graph and label points, how to identify points, how to identify the quadrant that they're in, and then going back to these questions where you have to graph an original figure, an image after you do something to those coordinates, like multiplying by -1 or subtracting 3. And don't forget how we label those. We just put a little tick mark after it to indicate, almost looks like a little apostrophe. We put that after it to indicate a new point that we've done something to get that new point. So knowing those concepts, I think, are honestly the most important things for this lesson. There are some extra things in here that are a little higher level to see since you are pre-algebra students, but the majority of it won't be on your test or a quiz or anything like that. Just again, graph and label points, points, identify the quadrants, and then be able to do those two questions with the rectangle and the triangle that were shifted in some sort of way. All right, thanks for listening.